our Bloom Online Study Center in collaboration with UBC-Star TV.
Meet excellent teachers like Mr. Patrick Kimule,
one of the experienced teachers in the country. As Bloom Study Center, we work with different teachers in the country,
partnering with schools and parents.
Enroll your child now for online lessons at Bloom Study Center. We offer all subjects for both R and A levels, catering for primary level. For inquiries, call 077-628-4672 or 07058-09796. Don't miss online lessons.
Yes, you're welcome, dear viewers. We are back here to our program Tusome. I'm Joseph Jobs Kaira, and I'm here for organic chemistry. I'll be taking you through organic synthesis. It is Bloom's Study Center and UBC-Star TV bringing you this good program. At Bloom's Study Center, you can contact us via our WhatsApp number 0776 26 28 46 72, 0776 28 46 72. Personally, you may contact me at josjobsacademia@gmail.com. Now, we are here for our simplest branch of chemistry that most of the students enjoy. But before I proceed, remember, dear viewers, that COVID-19 kills. I've already got my 2 doses and I'm well to go. Please go to the nearby vaccination center and get vaccinated. I'll be using this board and also our PowerPoint presentation for this lesson. Let's have the first slide and then we'll be well to go. When you look at your TV screen, you see that slide showing you organic chemistry. You see that slide showing you organic chemistry. Sorry for that interruption. My contacts are there. Let's proceed to the next slide. In our next slide, we are showing you our examinable areas in organic chemistry. We are showing you our program, our examinable areas in organic chemistry. We are looking at organic analysis, how to outline mechanisms, distinguishing organic compounds, synthesis of organic compounds, and applied chemistry. But I'll be looking at mainly that 4th section that you're seeing on your screen, the synthesis of organic compounds. Our next slide. That question you see on your screen is a question that is an example of what we deal with in organic analysis. But it's not our aim today. We shall look at that in our next session. Next slide. That is a question about mechanisms. Mechanisms, complete the question and then outline a mechanism. That will also be for another time. Then in next slide, that is a question, that is a general question that involves explanation of observations and how to illustrate your answer with equations where necessary. Such questions, examiners are very much interested in them these days. So when you come and approach such a question, you should always be very careful. Next slide. That question there is also a good question where you are asked to identify a reagent that can distinguish compounds. Examiners are very much interested these days in observations and equations for the reactions at the end after you've given the observations, you've stated the reagent. You should also be well conversant with outright balanced equations for the reactions. We proceed. Now, our aim today is that organic synthesis you're seeing there. And what should you note during organic synthesis? During organic synthesis, dear viewers, I want you to note were the following. The first one is that read and understand the question. Clearly observe if it requires you to write equations, or if the description does not require equations. We have our first question there. It says, describe how 2-phenyl ethanol can be prepared from ethanol. In other words, we are converting ethanol to 2-phenyl ethanol. The question is very clear. No equations are required. You're told not to include equations in your answer. So what do? Try to do some side work. You cannot approach this question directly. This question was set in last year's paper 2, and most of the students misfired. They had to go on and write equations, and they lost 20 marks. They were working out of 80 for paper 2. What do? Write the formula of the compound you want to convert to the other. This is ethanol. You want to convert it to 2-phenyl ethanol. So you should very much, you should be aware of the nomenclature of these compounds. So this compound here is what we call 2-phenyl ethanol. This is carbon number 1, and this is our carbon number 2. This is your carbon 1, that's your carbon 2. That's why we call it 2-phenyl ethanol. Okay? Sorry, I have to make a correction here. For 2-phenyl ethanol, this should be CH2, CH2, OH. This should be your carbon number 1. The carbon that has the OH group is carbon number 1. And then the carbon that has the phenyl group becomes carbon number 2. You count the carbon atoms depending on the hydroxyl group. So what do? What you should do is very simple. First of all, try to do the synthesis using equations as side work. So this one will first of all be converted to a benzene ring. And to get the benzene ring, you must, of course, get ethanol. You must get ethane first. How do you convert ethanol to ethane? You proceed through ethene by first of all dehydrating the ethanol at 180 degrees Celsius. This gives you ethene. Then add bromine in the presence of carbon tetrachloride. This gives you CH2Br, CH2Br. I hope I have viewers from the West, Intare High School. You are very much following. Now this one here can be converted to ethanol by using ethane by using potassium hydroxide, ethanol, and then heat. This will give you ethane. That is your ethane. Now ethane can be converted to benzene using iron tubes or copper tubes, and you heat at a temperature of about 600 degrees Celsius. This will give you the benzene, and now there you're well to go. How do you get from benzene to this compound? To get to that compound, you must do acylation, Friedel-Crafts acylation. So to do that, I add that reagent in the presence of aluminium chloride. That gives me phenyl ethanol. Now I want to convert phenyl ethanol to that compound. I still have a journey to travel. So what do? I can now reduce this using lithium, aluminium, tetrahydride in presence of dry ether. So it gives me this compound here, a secondary alcohol, which I now want to convert to a primary alcohol. This one is 1-phenyl ethanol. 1-phenyl ethanol, and this is 2-phenyl ethanol. So what do I do to this? Finally, I can dehydrate using conc sulfuric acid. at 180 degrees Celsius to give me phenylethene. To give me phenylethene. Now, some students would add acidified water here. When you add acidified water, you're coming back to 2-phenylethanol, which we are not aiming at. So how do you avoid that? You can use Markovnikov's rule and look at the other side of it, which is anti-Markovnikov. So when you use Markovnikov's rule and you add hydrogen bromide here, it is the carbon atom that has excess hydrogen atoms that will get the hydrogen. This hydrogen will come here, and then the bromine comes here. So that will not help us. How do you avoid it? Let's use hydrogen peroxide, hydrogen bromide in presence of an organic peroxide, and proceed via the anti-Markovnikov's rule. Now, when you do that, you're going to get this compound here. You're going to get the compound CH. You're going to get this compound here. The hydrogen is going to come here to the carbon that has less hydrogens, and the bromine will come here. That's anti-Markovnikov. So now you'll have CH2, then CH2Br. From this point, you can go direct to your final product by using sodium hydroxide. The sodium hydroxide should be aqueous. It should be aqueous. And then you should heat. When you heat, you'll finally come up with your final product, which is 2-phenylethanol. If you didn't know the IUPAC name of that compound, you could not get it. It's a bit lengthy synthesis, and now we want to see how do you convert this to words. How do you make these words? So to make these words, you come here and try to write. You have your books, you're now writing. How do you convert ethanol to 2-phenylethanol? This is side work. Remember in our slide, they told us no equations were required. So dear viewers, especially those from the north, what will you say? You'll come and say that ethanol is heated at 180 degrees Celsius with concentrated sulfuric acid, actually with excess concentrated sulfuric acid, to form ethene. Ethene is reacted with the bromine in presence of carbon tetrachloride to form 1,2-dibromoethane. So if you don't know the names of these compounds, you cannot do this. Then the 1,2-dibromoethane is reacted with alcoholic potassium hydroxide solution. That word solution should be seen in the words. So it is reacted with alcoholic potassium hydroxide solution on heating to form ethane. This is ethane. The ethane is heated in the presence of iron tubes at a temperature of 600 degrees Celsius to get benzene, which is then reacted with ethanoyl chloride. You see, if you don't know these names, then you are not good to go. It's reacted with ethanoyl chloride in the presence of aluminium chloride, which is anhydrous. In the presence of anhydrous aluminium chloride catalyst to form this compound. What is its name? Because you're writing words. This is phenylethanol, a ketone. The phenylethanol is then reacted with an ethereal solution of, people call this lithium aluminum tetrahydride. I don't prefer that name. An ethereal solution of tetrahydrido aluminate 3. That's the name of that solution. Tetrahydrido aluminate 3. Don't put dots here. An ethereal solution of lithium. It's called lithium tetrahydrido aluminate 3. Or you can say it's heated with lithium tetrahydrido aluminate 3 solution in presence of ether, dry ether, to form 2-phenyl. This is 1-phenyl ethanol. 1-phenyl ethanol, which is then reacted with concentrated sulfuric acid at 180 degrees Celsius to form phenyl ethene. Phenylethene is then reacted with the dry hydrogen bromide in the presence of anorganic peroxide. This should be not any peroxide. It should be anorganic peroxide. If you know the example, you can give an example of dibenzoyl peroxide or benzene. Yeah, you can use dibenzoyl peroxide or any other peroxide that is organic. So this one yields, you should know the name of this compound here. That compound is called 2-phenyl 1-bromoethane. You can use that name, or you can call it 1-bromophenyl ethane. Then you heat it with sodium hydroxide solution to form 2-phenyl ethanol. That's the approach we use when we are writing mechanisms in words. Okay? You can see more of these in one of my books, Demystifying Organic Chemistry. We also have other books, Demystifying Physical Chemistry and Demystifying Inorganic Chemistry. If this is well understood, let's proceed to the next slide and see our next approach. That is a typical paper 2 question that was set last year, and most of the students failed it. I'm showing you how a question can be set, and it carries 20 marks. Next slide. Yes, dear viewers, that's our second point when you're doing organic synthesis. It is also a point that you should note. Chemistry is fun. Chemistry is not a mystery. I don't know why students take chemistry to be a mystery. Most students fear it. You pass in town, you tell a person that you're teaching chemistry, they run away from you. They think you are a terrorist. Chemistry is not terrorism. Chemistry is a very enjoyable subject. Now, when you look at your screen, you're seeing the second point, which says you should acquaint yourself with the correct IUPAC names of most organic compounds, especially if the question does not require you to write equations. Names of reagents and intermediates need to be mentioned too. You can see an example there. Without using equations, convert 1,2-dibromobutane to ethane 1,1-diol. Convert 1,2-dibromobutane. 1,2-dibromobutane is this compound here. Butane has 4 carbon atoms. So this is butane alone. Now when we talk of 1,2-dibromobutane, we mean that one of the hydrogens here is substituted with a bromine, and the other hydrogen here is also substituted with a bromine atom. So that is our 1,2-dibromobutane. We want to convert the 1,2-dibromobutane to ethane 1,1-diol. That is ethane 1,1-diol. On the same carbon atom, we have 2 hydroxyl groups. So that is ethane 1,1-diol. When you look at the number of carbon atoms in these compounds, this is 1, 2, 3, 4, and these are 2. Meaning somewhere I have to break a given chain that will give us 2 carbon atoms. How are you going to do that? You must of all make sure this is converted to an alkyne, because that's the first step that will ease your work. When you convert it to an alkyne, then proceed by converting it to an alkene and then ozonolize. Break the chain by ozonolysis. Okay? And remember, please, whenever you're doing ozonolysis, you should use symmetrical alkenes. So not to waste time, I'll say I'm going to use potassium hydroxide. Potassium hydroxide. I think people always also use this. They call it alcoholic. Alcoholic potassium hydroxide. And then heat. That's the same as what I've done in the previous description where I said potassium hydroxide stroke ethanol. It's the same thing. When you heat this, you're going to use, other people prefer putting the word excess. When you heat this, you're going to get an alkyne. That is our alkyne, which alkyne is called but-1-ine. The alkyne is this one here. This alkyne here should be converted to an alkene. How do you convert it to an alkene? You use hydrogen in the presence of Lindlar catalyst. So hydrogen in the presence of Lindlar's catalyst, don't heat. People don't know Lindlar's catalyst. It's the same as palladium supported on barium sulfate. Barium sulfate gives the support to palladium, and the whole catalyst is poisoned by quinoline. But those details may not be relevant for now. So when you use hydrogen in presence of Lindlar's catalyst, you'll get an alkene. Which alkene we call but-1-ine. That's the alkene you will get. Now this alkene here is to be ozonolized. But if you are to ozonolize this alkene, you'll get two aldehydes. Which two aldehydes are both present in almost the same concentration in the solution. So how are you going to avoid that? Make sure you get a symmetrical alkene out of this. And how do you get a symmetrical alkene out of this? Most people here would do ozonolysis directly and then get, actually if you do the ozonolysis, there is cleavage at this point. You're going to get two aldehydes which will not give you the desired product. So to avoid that, what are you going to do? You're going to use acidified water and heat or warm. When you do that, you're going to get an alcohol. The alcohol you get in this case is not a primary alcohol. It is a secondary alcohol. That is butane 2-ol. After getting butane 2-ol, we still have a way to go. You're going to dehydrate using conch sulfuric acid at 180 degrees Celsius. So when you dehydrate, you're going to get CH3, CH, CH, CH3. Yes, there is a student I'm seeing there. I'm seeing you getting perplexed. You're wondering how I dehydrate this and then I get the double bond between these carbon atoms and not these ones. When you put the double bond here, that means the carbocation you used to get that alkene was the most unstable carbocation. I think you remember that mechanism that involves a hydride shift. So when you dehydrate any alcohol that has 4 carbon atoms, you get a symmetrical alkene. You should always note that. Then here, we can do our ozonolysis. Ozonolysis is done in 2 steps. You should show step 1 and step 2. What is step 1 is in ozonolysis? Step 1, you use ozone, presence of carbon tetrachloride, at a temperature of greater than 20 degrees Celsius. Then the second case after ozonolysis, you hydrolyze in the presence of zinc and ethanoic acid. I've seen people using zinc and ethanoic acid alone, but haven't seen that in any literature. So water is very important because this is hydrolysis. Now when you do that, you're going to get an aldehyde. You get 2 molecules of this aldehyde because there is cleavage at that point. And finally, you can convert the aldehyde to the diol by first of all using phosphorus pentachloride. That gives you this product here. And then at that point, you can do our last step that we did in the previous reaction by using aqueous sodium hydroxide. Don't forget to heat, dear students. I hope you're following and you're enjoying this lesson. Now, our question said we are not using equations. We are using words. So you can get your books and see what to write. What are you writing? You're saying that 1, 2, because I told you names of compounds are very important here. 1, 2 dibromobutane is heated with excess alcoholic potassium hydroxide solution to form but1-ine, which is then reacted with hydrogen in presence of Lindlar's catalyst to form but1-ine. The but1-ine is then reacted with the concentrated sulfuric acid and then diluted with water on heating to form butan-2-ol. Or you can simply say the but1-ine is reacted with acidified water on heating or warming, any of the two is acceptable, to form butan-2-ol, which is then heated or dehydrated using concentrated sulfuric acid at 180 degrees Celsius to form but2-ine. You're writing words. Now here is where most students messed up last year at this point. There was a question that involved ozonolysis as one of the steps. And I've told you always name all intermediates involved. Always name all intermediates involved. So what do you say? But2-ine is first of all reacted with ozone. This compound is called ozone in presence of carbon tetrachloride at a temperature less than 20 degrees Celsius to form an ozonide. You don't know the name of that ozonide. The intermediate after step 1 is an ozonide, which ozonide is then hydrolyzed using zinc and ethanoic acid to form this compound here is called ethanol. It's an aldehyde. Ethanol is then reacted with phosphorus pentachloride, don't heat at this point, to form 1,1-dichloroethane, which is then heated with sodium hydroxide solution to form ethane 1,1-diol. Hope that is perfect. Chemistry is simply fun. So whenever I'm doing these things, I'm just enjoying. And I know all of you seated at your home, perhaps taking a cup of tea and water, you're enjoying this. People from Masaka Secondary School, I know you're enjoying. I'm your OB there. So let's proceed to the next slide and see what happens after this. When you look at your screen, you see what the next slide is suggesting. The next slide is saying we have point 3. Point 3 says it's recommendable that you use the shortest possible route. This stops you from doing mistakes and avoiding unnecessary errors. Okay? Also try to make the synthetic steam continuous to save both time and space, especially in paper 1 where space is usually a bit inappropriate. Write equations to show how 1-chloropropane can be converted to ethanol. This time, they have taken us back to our old method where we should write equations to show how 1-chloropropane can be converted to ethanol. How do we convert 1-chloropropane to ethanol? 1-chloropropane to ethanol. This is 1-chloropropane. We are converting it to ethanol. There are very many routes that can do that. These are 3 carbon atoms. We are reducing them to 2. But you should always think of the shortest route to save your time and space. What shall I do to do this? What shall I do to do this conversion? To do this conversion, this is what I'm going to do. I'm going to first of all use sodium hydroxide and heat I'm now going to be a bit faster, to give me propanol, which is then dehydrated, to give me propene. That's my propene. I don't prefer ozonolysis at this step because this is an unsymmetrical alkene. To simplify my work, I would go through a symmetrical alkene. How do I get a symmetrical alkene from this? I first of all convert it to an alkyne. Bromine, carbon tetrachloride, CH3, CH, bromine, CH2, bromine. Potassium hydroxide, ethanol, heat, CH3, CH, C, triple bond, CH. Step 1, sodium, solid, liquid ammonia. Step 2, that one gives you an acetylide. Step 2, you add one carbon atom here. And that will give you this kind of alkyne. That kind of alkyne can be converted to an alkene. To an alkene of this kind. And then you ozonolyze. Step 1, ozone, carbon tetrachloride, less than 20. Step 2, water, zinc, ethanoic acid. That one gives you ethanol, which ethanol can then be reduced using a reducing agent to give you that. These are how many steps? 1, 2, 3, 4, 5, 6, 7, 8 steps. Probably, why am I doing this? I want you to stay at home and think of the shortest route possible that can take you there. You may probably be thinking of very many other routes that can take you here. Somebody could use this step. I have seen students always using this. Potassium hydroxide, ethanol, heat. And such a reaction is likely to give you an ether. It's not appropriate for the synthesis. This being a primary alkyl halide. So you should avoid that. Let's proceed to the next slide. In our next slide, we are seeing point 4, which says, make sure the conditions used are correct and the state symbols of reagents and symbols of the reagents themselves are correct. For example, you have seen me using liquid ammonia in my conversions here. It should be strictly liquid because ammonia can be a solution. Know when to use sodium hydroxide solid and when to use aqueous sodium hydroxide. Know when to use solid ammonium carbonate. For example, you have the carboxylic acid and you want to convert it to an amide. You have a carboxylic acid and you want to convert it to an amide. This is my carboxylic acid, ethanoic acid. If I want to convert it to an amide, I usually use ammonium carbonate and heat. This ammonium carbonate should be strictly solid. Students usually mess up for such a case. This gives you ethanamide. I'm emphasizing state symbols wherever they are required. Okay? You're doing a decarboxylation. Same carboxylic acid, and you're using sodium hydroxide, calcium hydroxide, and then you're heating. This should be strictly solid to give you methane. But why do you go this way? Yet you can simply write the word soda lime and heat. Okay? You're converting an alkyl halide to an alcohol. Use sodium hydroxide, heat. The moment you do that, you're not specific. The sodium hydroxide, is it solid or liquid? Sodium hydroxide can be a liquid when heated to melt. It can be a solution. It can be a solid in pellet form. So please specify that this is aqueous. You have seen a conversion of this kind. Somebody can tell you to convert benzene sulfonic acid. Benzene sulfonic acid to phenol. This is where most students mess up with their state symbols. What do you usually do in this synthesis? What you should always do is this. Get the benzene sulfonic acid. It is that compound. Sodium hydroxide aqueous at first. When you use aqueous sodium hydroxide at this step, you will get a sodium salt of the acid. And then in the second step, what we usually use is solid sodium hydroxide. I'm emphasizing states and their importance. In case you don't specify which sodium hydroxide you're using, then you have challenges. This occurs at a temperature of 360 degrees Celsius, and we fuse. Fusing means we are using solid sodium hydroxide. Okay? At that point, we get a sodium salt of phenol, sodium phenoxide, which you can simply dilute with hydrochloric acid to finally come up with your phenol. Why have I done this? I'm emphasizing the importance of state symbols, my dears. Next slide. When you look at that slide on your screen, you're seeing point, that is point 4, next slide. You should know when to apply heat and when not to. You should know the common reagents whose symbols are not written correctly. People usually write symbols wrongly. Somebody is writing lithium aluminum tetrahydride and he does this. Who are you chasing? This is not letter L. And in chemistry, we are always strict with the chemical symbols. Write letter L very well. You're not chasing anybody. Okay? Somebody is writing sodium hydroxide. I've seen people writing these things. Okay? You're not chasing anybody, right? Neatly. Okay? Somebody is writing phosphorus pentachloride. If these are your lines, you should know capital P is written that way. Pentachloride. So if you write P like this is a lowercase letter p. And for us here, we're always interested in symbols. Please make sure you write correct symbols. Somebody's writing iron 3 chloride. Let's be careful, my dear students. Okay? Write iron very well. Iron 3 chloride. You're not chasing any person. Okay? We can move to the next slide. Can move to the next slide. In our next slide, we are seeing another point in organic synthesis. Point 5, let's proceed. Point 5 said you are advised to write reagents first and then follow them with the conditions. This is common when using acidified water, oxidizing agents, and alcoholic solutions. Okay? Don't write, for example, using acidified potassium permanganate. You're writing that reagent and you're using it in synthesis. I've seen people writing it this way. I always advise students to write the reagent first. This is the reagent. The potassium permanganate is the reagent. The acid is just a condition to acidify it. Don't begin with the acid and then write the, don't begin with the condition and then write the acid. For example, you are using alcoholic potassium hydroxide solution. Okay? You should write the reagent first The reagent is potassium hydroxide. And then ethanol is just a condition. Then you heat in a synthesis. Let's proceed to the next slide. Point 6. Thank you for viewing us, members. You can get more on my YouTube channel, which is Joseph Jobs Kaira Chemistry Channel. There are very many lessons about chemistry. We are synthesizing. Let's rewind. There is a synthesis we are doing. Point 5, there is a synthesis there. That synthesis is methyl propanoate from propyne. Methyl propanoate. This is methyl propanoate. We are getting it from ethine. How do you convert methyl propanoate from ethine? Look at these 2 carbon atoms. You must of all get ethanoic acid. Which ethanoic acid you will esterify with methanol to get this ester. You see how chemistry is interesting? So you must think of how do I get from ethine to ethanoic acid. To get ethanoic acid from ethine, I must get ethanol first, which ethanol I will oxidize. Dear viewers, what do? Convert the ethine to ethanol. To convert ethine to ethanol, you first of all convert it to ethene. How do you get ethene from ethine? Use hydrogen in the presence of Lindlar catalyst. That will give you CH2CH. It gives you an alkene, which is H2C CH2. That is ethene. Some people, I have seen them using this. They use hydrogen in presence of nickel, 150, to do that conversion. When you do that, you're likely to get an alkane. It will be very hard for you to isolate the alkene. So you may not easily isolate the alkene from the mixture. To avoid that, we poison the hydrogen with what I told you Lindlar's catalyst is palladium supported on barium sulfate, and quinoline is the poison. Why do we poison the catalyst? To slow down the conversion of the alkyne to the alkane. So when you do that, you'll get the alkene instead of the alkyne. Now, that is the Lindlar catalyst, is simply that mixture there. So what do we do after getting ethine? I know you can now proceed by using step 1, conco sulfuric acid, 2, water, and then warm. Now people are getting confused. What does that mean? This is what you have always been calling acidified water. You write acidified water, but it usually occurs in 2 steps. It doesn't occur in 1 step. So I've liked to separate it this time. But even if you use acidified water and warm, that's fine. This gives you ethanol. This gives you that enjoyable drink that probably some people are taking this morning. People are working, people are on business, then people are sanitizing their throats. And people say the ethanol sanitizes their throats and stops COVID. I don't know the proof. I'm still in the lab trying to prove that. Now, after getting ethanol, you can oxidize the ethanol using an oxidizing agent, potassium permanganate, in the presence of the condition now, the acid. You must heat. When you heat, this strictly gives you ethanoic acid because you are using a strong oxidizing agent. Finally, you can do esterification to get our ester. These 2 oxygen atoms come from the acid, then the methyl group here must come from an alcohol. Reaction between an alcohol and the carboxylic acid gives us an ester. What condition do we need? We need concentrated sulfuric acid. And please this reaction is very slow. So make sure you heat to make it occur faster. What have I been emphasizing here? Reagent first, condition. Reagent first, condition. Next slide. Oh, sorry, this is not yet. We are saying methyl propanoate. We are saying methyl propanoate. We must have 3 carbon atoms. I think I need to correct this. I'd seen methyl ethanoate. So how do I get methyl propanoate from this? We must add 1 carbon atom here. We must add 1 carbon atom. I hadn't seen this, sorry for that error. So what do? We get the alcohol and convert it to an alkyl halide using phosphorus pentachloride. And then you use potassium cyanide. It will give you this. Use potassium cyanide in the presence of ethanol, and then heat. It gives you that. Then you can go to propanoic acid. The propanoic acid is got by using acidified water at this step, and then we heat. So after getting the propanoic acid, then we do our last step, which is methanol, conc sulfuric acid, heat. That gives you methyl propanoate. Thanks for viewing and learning. We are in our program to Some, once again to remind you, and we shall always be doing these enjoyable lessons. Okay, so we proceed to our next slide, which is point 6. Any wrong name of a compound, reagent, wrong spelling, inappropriate condition, any wrong step in a synthetic scheme makes everything after it wrong. Let me give you an example. We are converting bromoethane to propan 1-ol. Bromoethane to propan 1-ol. To emphasize point 6. We are converting bromoethane to propan 1-ol. What are we going to do in this synthesis? Look at the number of carbon atoms, 2, 3. That means somewhere we shall elongate the chain. I'm going to do 2 steps, two methods, and you'll see how students go wrong. I've seen a student, one is there, and he's thinking of this. Somebody is seeing that student 2. The student is getting ethene. And then he proceeds using chlorine, carbon tetra, chloride, CH2 chlorine, CH2 chlorine atom. Then uses potassium hydroxide, ethanol again, and the student is heating to get ethane. That student is using hydrogen, Lindler, to get ethene. Or the student may prefer to elongate the chain at this point to get the 3 carbon atoms by using step 1, sodium, liquid, ammonia. The same student is now adding 1 carbon atom, because those are 3, CH3Br. That student now gets CH3CH. This should be a terminal alkyne to do that conversion. The student continues enjoying the synthesis. Okay? So the student continues enjoying the synthesis. Then he uses hydrogen again, Lindler, catalyst to get the alkene. And then uses antimakonikov. If you want the bromine here, you use antimakonikov. That student is getting CH3, CH2, CH2 bromine. And then he uses sodium hydroxide, and the student heats. that student is very wrong because he's violating our point that I've been talking about. Why? This step here will never give you a thin as the major product. The rest of the steps are very fine, but the first step is wrong. So we look at your work and make you lose marks, yet you've done good work afterwards. So how do you avoid that? Primary alkyl halides give ethers on reacting with the alcoholic potassium hydroxide and heating. So to avoid this, you could go through this route. Use potassium cyanide ethanol and heat. This will give you this kind of compound, a nitrile. We call this a nitrile. Oxidize the nitrile using acidified water and heat. This will give you a carboxylic acid, which is propanoic acid, which you can now reduce using lithium tetrahydroaluminate in presence of dry ether. That gives you the propanol. So that's the best way we could do that. Thank you, viewers, for attending this session. We can now welcome questions for those of you viewing from home. If you have any questions, you can call in the studio line and then present your questions. I'll be answering them. You can call in as you also think of other issues. We shall do more of the synthesis in our proceeding lessons after this. We shall always be doing some synthesis. I'll give you the do's and don'ts. When we complete it, then we shall be able to see what next we can do. Okay, very much. Thank you very much for viewing. You can inbox me the questions on our WhatsApp group, or you can contact me via my email. Well, thank you for viewing our program, Tusome. We once again meet next week. I've been Joseph Jobs Kaira from Makerere College School. You can get any of my editions, Demystifying Organic Chemistry, Physical, and Inorganic. Have a nice time. Vaccinate. COVID kills.
We are Bloom Online Study Center in collaboration with UBC-Star TV.
Meet excellent teachers like Mr. Patrick Kimule,
One of the experienced teachers in the country. As Bloom Study Center, we work with different teachers in the country.
partnering with schools and parents.
Enroll your child now for online lessons at Bloom Study Center. We offer all subjects for both R and A levels. Catering for primary level. For inquiries, call 077-628-467 or 07058-09796. Don't miss online lessons.